Hello, everybody, and thank you for joining us. Welcome to Shaper Sessions. We got a fun one tonight. We are doing box joints. We're going to spice it up a little bit. We're going to do a lot of box joints, mix in a new technique with box joints, and we're going to build. By the end of it, we're going to assemble a full project done entirely on tool. I am joined today by my friend Noah.
Hey everybody, nice to see you this evening. I'm going to be here to be Jake's second in command, but I'm going to let him run the show and answer questions as they come in. Excited to get into it.
It's going to be a lot of cut time today, but let's kick it off. So we're going to be building a kind of a long, tall, single drawer cabinet. Just kind of a fun, funky design that the entire casework is going to be done with box joints. The drawer itself is all box joints, and the legs are using box joints. Now, for those of you that aren't familiar with box joint, it is an on-tool extension.
I think Goose has got a sweet rendering that you're kind of sheepish about, but I think it's beautiful.
Yeah.
To show, so get ladies and gentlemen an idea of what's going on here.
Yeah. So let's hop over to the illustration. This is what we're going to be building today. So about 36 inches tall. You can see the top case is entirely all box joints. None of this is going to be done on a computer. We're just using the power tools I have in the shop and Origin.
I was going to say, well, that may look like a rendering from a computer. That's actually just out of Jake's very talented mind and hand.
It's starting to look... It's dawning on me. It's starting to look like a walker from Star Wars now. Not intentional. Anyway, so that case, top case, is all going to be box joints. The legs are the part that I'm pretty jazzed about. We're going to do bridle joints, because what is a bridle joint but just a 3-pin box joint? So if you joined us on our IG Live on Tuesday, I went into that. If you didn't, I'm going to go back into it today, and let's start there. So I've gone ahead and done the majority of them, but I've left 2 sides undone. I'll just come down here and show you on this desk cam. So I got that one done, and we're going to do the mating pairs for this side. Everything today is going to be done on workstation, which is fantastic because it means everything's going to be really repeatable. Got a lot of matching parts, so I don't want to be re-gridding every single time. I can just pop it into my workstation and keep carrying on. Start off with our support bar into its zeroing position. Another thing I always do, and I'll go more into this when we talk about standard box joints, but I have my reference face marked. So this face here is the side that I'm actually going to be pressing up against my reference pins on my workstation, or my vertical alignment pins. I'm going to use that same face every time. When I'm rotating and doing the other side, I'm continuing to use that face. That just keeps everything nice and tight and doesn't, instead of twisting or doing anything like that, I want to be using that same face. So, into the workstation. We're working with 1.5 by 1.5 cherry, and the case is at a 3/4 cherry. That one cranked, and there we go. Give it a visual check, make sure that I'm nice and tight against my vertical alignment pins, and I'm flush with the support bar. Don't want that to move on me, so I'm cranking down on the clamps. All right. I have my engraving bit inverted up into the collet, hand tight, and then the spindle tightened. That's how I'm going to be making my grid. I want it to be a nice crisp grid, and I don't want to introduce any potential errors that using the edge of a cutter might do. I always like to reiterate that every single time we talk about grid. I may not do it every single time during a session, but that's just for speed's sake. So I'm not changing cutters necessarily, but if I'm doing something I care about or something that I'm doing a set of and I don't need to regrid, I'll take the time to invert that engraving bit and make sure that it is a nice tight grid. Lower and down. Boom, boom, boom. And we can hop over into our Create tab. We're going to be living in this Create tab right under Box Joints. And we got our settings coming up. So, first and foremost, our bit size, 1/4 inch. The thickness of our material is going to be 1.5. Same with the width, 1.5. And the total number of pins. Now, just to show you what that looks like, I can adjust the number of pins as much as I like. I can go as chunky a pin or as thin a pin as my cutter will allow. But since we're doing a bridle joint right off the bat, we're just going to do 3 pins. 3 pins. I'm going to bump up that glue gap. Glue gap is a built-in offset, so that instead of using offsets in your cutting tab, glue gap just allows it to be, you know it's there, it's applied evenly on both part A and B, and the kind of standard recommended is 0.005. I'm just going to add a hair to that because I'm working with some pretty dense wood. Nice and easy. Place it at 0, 0, right there at the bottom left corner. And I'm ready to go. Okay, so you'll see, given the size of my cutter, I don't have to do any pocketing. But if this, later on, we're going to have to do a pocket first because that gap gets bigger and I need to clear out the material on the inside. But let's swap to our cutter. Since we're going 1.5 inches deep, we got to use that long cutter. Anyone that's done any of the premium projects like the shop stool or the lamp, you'll be familiar with this cutter. It's got 1.5 inch long cutting flute. I guess I'll bring it down here. 1/4 inch bit, 1.5 inch long cutting flutes. Couple tricks that you need to consider when you're using a bit like this. It is long and it flexes, especially because it's only 1/4 inch. You have to be very ginger with it when you're going against a hard material, or just take considerable finish passes, because as you're cruising through wood, it will actually ever so slightly flex away from it. So you just want to keep that in mind when you're going through your projects. Another thing is, when I chuck this bit up, I want to make sure that, if you come down here, that I'm putting it in the collet right where that cut grind ends. And so I'm grabbing a completely solid chunk of the shaft. And as I bring it into the spindle carriage, I just let it fall. Don't let it fall because it's sticking out too far. It's actually contacting the top of workstation right now. I'm just going to choke up on it a little bit, maybe 1/8 of an inch, maybe less, just so it's hovering above my material surface, so that when I retract, I'm not running into it, I'm not damaging my workstation or my workpiece. And Z-touch. There we go. Again, I'm working in, it may be hard cherry, but it's end grain, and I trust my bit, and I've done this a couple times. I know that I can do 1/2 inch depth passes. Normally, if I'm doing cross grain, I'd be doing 1/4 inch depth passes, but you'll see in a moment, because you're cutting into end grain, it just comes off in really nice little curls. So 1/2 inch depth passes, and starting with a 0.02 offset. Okay, I'm going to get cutting.
All right, everybody. So as Jake gets started on this stuff, I'm going to talk to you a little bit about box joint. You got to see how that works, but give you a little bit of a history lesson on it. So box joint hasn't always been part of Origin, and that's something that's it's actually quite cool about a power tool that gets regular software updates. So box joint was added to Origin in September of 2019 on the Golden Gate release, and obviously since then, we've been playing with it and finding interesting and new ways to use it, like Jake's showing you today. But lots of very good things come in those software updates. So it's something that we're really excited about at Shaper, and something that's really unique about Origin as a power tool that improves over time, rather than just sort of gathers dust or gathers wear. Origin gets better over time. So that's really that's kind of an interesting one. Box joints are definitely a very cool way to put your projects together. There's a lot of surface area. They're extremely high strength, and they're pretty straightforward and simple joinery. And there's kind of a beauty in that simplicity. So it's fun to put together a project with a lot of them. Traditionally, you would be setting up either a router table or a table saw system to cut box joints. Obviously, in Origin, it's very simple to set that up, as Jake demonstrated, and very easy to put your tolerances in as well. So, and for those of you that are not familiar with Origin in general, what Jake's doing right now is actually moving Origin around the cut roughly. But as we see on the screen, there's actually this white circle in the center, and that circle is we call that the corrective range. And the corrective range is where you can safely move Origin around your cut profile while it will correct for you. And so what Origin's doing is watching out for where Jake's moving right now, and actually compensating for Jake's inaccuracy. So Jake's just sort of in charge of the course motion, and Origin is doing the active correction. So that's a really powerful thing when you're talking about sort of extending the human capabilities with a machine like this. So it is a plunge router. It is a robot. It's sort of it is very human involved. So that allows for a lot of flexibility. And what we're doing here today in this project is pretty interesting, because Jake just did a drawing of this project. We haven't touched a computer. We haven't really done anything in that vein. And Jake's able to actually just get going on this project with all on ToolCAD.
Part one of our bridle joint. We're going to hop over to its mating part now.
Okay. So Jake's using, for those of you that aren't familiar with Workstation, Jake talked a little bit about it, but there's some really cool stuff that's going on there. Jake's using the support bar as a zeroing in stop. So that's really powerful for repetitive cuts. Jake only has to set up the workspace and grid once for this project, or rather for each of these parts, and then he can kind of proceed to batch through these parts, just changing from the A side to the B side with the Box Joint Basic app. And that's really powerful in a production setting, or even just in your home shop where you're trying to make a few dining chairs, or make a set of bedside tables. Anything where you're going to be making a lot of repetitive cuts, making the same part over and over again. That's a really valuable thing. So when we developed Workstation, we wanted to make sure that one of the things that it did best was repetitive cuts. It was easy setup for repetitive cuts that didn't require you to have to rescan or grid. The Workstation has pre-applied shaper tape, so it just makes the whole process that much easier when you go into the workshop to get going. There's not really a lot of fussing around to get your project started. So yeah, so right now Jake is cutting on what looks like the A side, but it's actually quite easy to swap between A versus B. And so what that means is essentially on a box joint, you're kind of mating two parts together, and where on part A you would have pins, part B there would be no pins, right? They're offset from one another, so they interlock. And the A part and the B part are set up automatically for you with the box joint basic app. So you just place one file, and it's very easy to swap between the two of them. So, and for touching off, I think we've got a question coming in here from Sandy Esman. Why use the engraving bit rather than the 1/8 inch bit for touching off and gridding? And there really is the only answer there is that the engraving bit has a much shorter grind on it. Really, what we're trying to do here is establish a really strong, a very known size in the pin that you're using to grid with. And so the easiest way we found to do that, and kind of the longest reach that we've kind of cutter that comes as standard with Origin, that has the kind of longest shank on it, which is really what we care about, that precision ground 1/4 inch shank. That's why we call for the engraving bit. But really, it doesn't matter what you use so long as you know the diameter is really consistent on that. The reason not to use just say a regular end mill is because once those are ground, the flutes are ground, they are no longer 1/4 inch. And they're also a little sharp, so they can scratch things up. And there's a few other issues there. But really the main reason and the main thing to keep in mind is just to really have a known quantity there, so that you know that when you're putting in a 1/4 inch or whatever you input into the value for the grid bit diameter, that you can trust that that's correct. So Jake, walk us through what just happened.
So I just did a test fit. Just wanted to make sure that I'm cutting my positive, or this particular piece, to a 0 inch offset. So now that I'm cutting its mating part, I can adjust that negative offset to get that fit that I want. So it's at 0, 0 right now. It could hammer together, but I don't want to put undue stress, especially on the grain orientation going that way. So I'm going to take an additional 3/1000th of an inch, so a negative 3/1000th offset off either side. I think that's going to be the perfect fit.
And this is one of the things that's just crazy powerful about Origin, is that you can, on the fly, regardless of the cut file that you've brought to Origin or the file you've created on board Origin, you can make those adjustments and make changes after you've done test fits, after you've kind of tested your parts with the real world. You can make those real world adjustments so that the fit is just perfect. It really depends on the project, and depends on kind of how you're trying to assemble things, whether you want it to be like a press fit, or you want it to be loose, or you want to allow room for glue, or you're dealing with a complicated assembly and you want to kind of make sure that things are all have a little bit of slop so that it will go together and not bind up on you while you're trying to get it glued up. It just leaves you sort of in control of your fate there, rather than the size of the drill bit you happen to have, or the size that you've happened to cut something to, without having to fuss around too much.
All right, there it is. Our mating parts are good to go.
Beautiful.
And
I'm so excited about this bridle joint thing that Jake's been going on about. It's so much fun, because this really never occurred to me.
Yeah.
Until Jake's Instagram live earlier this week, and that just kind of it tickled me. I really enjoy kind of discovering all the new and different ways that we can kind of bend Origin to our projects and make it easy to make cool stuff.
Exactly. Okay, so for these legs, I already went ahead, since this session is about box joints, but I just want to point out that I have already cut motors and tenons on the top of that, and that's how it's going to integrate into the case. Speaking of the case, let's move to it. We have 14-inch by 10-inch panels. mating parts already cut, but I'm going to cut both an A and B here so we can do a final assembly and get that put together. Only going 3/4 of an inch deep, so I can adjust my workstation to accommodate that, moving the clamping shelf up a notch. There's 3 settings on the clamping face. And do you remember what those measurements off the top of your head are, Noah?
0, 25 millimeters, and 50 millimeters.
There we go. So you'd use that 0 in the case when you integrate shelf into the workstation. You would come up all the way to the top. I'm also going to use a different kind of clamp. You can use the standard clamps that come with the workstation for something wide like this, but you can also use sliding F-style clamps. And it really all depends on what you're trying to fixture. So same thing as before. I have a little X on my reference face that I'm going to rotate around. And put the support bar into its zeroing position. All right. Pressing nice and firm upward and over to the left. Getting everything cranked down.
So we really built Workstation to be flexible. So you can see Jake's got one setup to cut the bridle joints on the set of legs that he's got there, and this is a completely different setup for cutting the sides of panels for casework. It really is a tool of many sides, and you can really sort of set it up for almost any project. We've done lots of really interesting stuff with it. We've seen lots of really interesting stuff done. You can make custom fixtures for it. You can use it in really creative and different ways. Just build it to suit your project essentially. And actually, on Shaper Hub, Sam created a sort of toolkit of all of the profiles that you need to make different fixtures and sort of things to work on the clamping face or on shelf of the shelf of Workstation. So if you go on Shaper Hub and look up Workstation, I think it's called the fixturing kit or something like that. That is just such a cool resource. Not only can you make your own replacement shelf tops, but you can make different shelf tops that have, say, hole patterns in them or T-tracks or all sorts of interesting stuff. There's may actually be a whole section on kind of fixtures and stuff on Shaper Hub where you can take a look at that. But if you search Workstation on Shaper Hub, there's actually a lot of really cool stuff that both we've done and the community at large have done to kind of customize their workstations.
All right, just doing a new scan here to bring in. I always want to get a nice clean image of the piece that I am working on in this particular moment. So even though Workstation is the same field of tape, I may have quite a few different workplaces for different things. Workspaces, thank you. And I'm gonna, as often as I can, I'm gonna name those. I'm gonna be very specific about this is, oops. I'm gonna rename it. I'm going to just remind myself later on down the road, if I want to remake this entire project, I can just hop back to this workspace and not have to regrid. As long as my material and everything's the same, I'm good to go. So this is my long, tall box joint.
If you can remember what you called it.
Yeah, exactly. All right. Same deal, we're going to make a grid. Boom. 1, A 2, and a 3.
Is there any reason why, Jake, that you're referencing off the left side for all these parts?
Not particularly. I could do left or right. With the box joints, it all matters. Well, first, straight out of the box joint generator, it's gonna orient you around that bottom left anchor point.
Gotcha.
If I wanted to use another anchor point, I could simply place, copy, and then adjust.
And you will want to keep sort of the anchor points consistent with which side of the workstation you're referencing to, right? The left pins or the right pins on the clamping face?
Correct. All right, let's see how many pins. I did 9 pins on this one. And I kept that glue gap to 0.006.
Boom.
And I am placing at 0, 0.
Satisfying. Remember, anyone who's ever muddled through making box joints with kind of the traditional stepped fixture technique, this should get you excited.
Yeah. It's you don't have to have a bunch of different fixtures for each size of box joint you want to make. If I decided I want to do really fine fingers on this box joint, I could just add more pins. Okay. I can hover over. I realize I kind of sped through the swap feature, but if you're in design mode and you hover over your box joint design, it's going to give you the option to swap. So you go ahead and tap that, and boom. Now you're ready to cut part B, which is the parts that I'm going to be cutting for this. Now notice this whole area here is not part of my cut path, so I need to change this first to a pocket so I can hollow out some of the space. I'm going to put a fresh cutter in, just using the stock 3/4 or stock 1/4 inch cutter that comes with Origin. Because again, for this one, we're only going 3/4 of an inch deep. All right. Now, even though we're swapping between 2 different 1/4 inch bits, it can be easy to forget to Z-touch because you're not actually changing the bit size. Anytime I put a new piece in the workstation, I'm Z-touching, just to make it a point of habit. Kind of reground myself, reground the tool, and get ready to make accurate cuts. Okay. And my cut depth. Actually, yeah. And I'll set that as 0. I'm going to go through, I'm going to pocket this, then I'm going to change it back to an inside cut and work to my final offset, which is going to be 0 because I already have a baked in glue gap. All right.
It's really really cool that it's possible to to kind of change what you can how you're cutting these box joints, right? So it makes it pretty flexible. You could cut one big set of box joints over the whole width of this. That would just be two pins on one side, one on the other. And being able to switch into pocket mode allows you to be really flexible about what size you're doing. It's not relying on the size of the bit that you're using to cut those. So that's a pretty cool thing. You do want to be careful when you're in pocketing mode. You can see Jake's kind of going carefully along and making sure that he's not climb cutting, especially if you're taking pretty meaty cuts on a piece of hardwood. You're going to want to keep that in mind. So climb cutting is going to happen anytime the cutter is not kind of fully engaged in material and you're going against or rather with the direction that the cutter is spinning. It's sort of, and we actually have a whole session on materials and cutters, and there's good illustrations in that of what's going on. And in fact, I believe in our support section, there's also a nice little animation that Sam made to help you guys understand Klein versus conventional cutting. But you can think of it kind of like, say, if your lawnmower was to catch on something and you weren't holding onto it, it might run away. And it's sort of the same idea. The teeth on a router bit are sort of constantly grabbing against the material. And when you're conventional cutting, you're actually pushing against that sort of natural momentum. You're pushing against and resisting sort of the force of the router pushing back against you. And a climb cut, actually, the router can get pulled completely out of your hands if you're not careful. So it's something you do want to keep an eye out for. When you're doing standard inside and outside cuts, Origin figures that all out for you, which direction you should be going, so that you are always conventional cutting. But in pocket mode, because it's freeform, it's really important that you kind of take note, and you'll feel it actually. If maybe you've always felt this in pocketing mode, where the tool sort of likes, in some occasions, likes to grab and run away from you, that's a climb cut. And so if you were to approach that same cut, but going the opposite direction, say instead of pushing away from you, you snuck back behind it and pulled you, that would be a different direction of cutting, and that might help you achieve a little bit more stable of a cut and a cleaner result at the end of the day. Obviously with a pocket, you're not doing sort of the final profile. You're going to save that for an inside cut, but it's possible to have the whole thing run away on you. So you do want to be careful to make sure you're not doing that. Goose, maybe we can see the underside camera. See what Jake's up to there.
How's that look?
It's pretty good.
So that's my rough cut. Now we're going to come back in and change that from a pocket to an inside. And that's going to give me that nice solid cut path. Still want to do one pass with a offset, so then I can do a final pass after that.
So Jake's really going to take his time here. This is cherry. It's really hard material, and this is going to be a nice piece of furniture. So he's trying to have the best outcome possible here. So you really can set up your cut strategy to suit the project, right? If this was a piece of shop organizational cubby or something to organize equipment, or something to go on the cleat wall, probably wouldn't need to be as careful. You could just kind of bang through, and it might be a rough spot here and there, and you just want to make sure that your cut strategy, and by that I mean how many depth passes you take, how many offset passes you take, you want to tailor that to the outcome that you're hoping for. So in this case, Jake wants this to be really tight fitting, really clean. So he's going to do a couple of depth passes, and he's going to do a couple of offset passes. And that's going to sort of guarantee to him that the outcome is going to be what he's expecting, not going to have any surprise little divots or anything here and there. So this looks like to be, this is going to be Jake's finished pass. So he's going to take extra caution on this one, just to make sure that his input to Origin is as smooth as it can possibly be. Origin does an amazing amount to correct for you, but the more smooth your input in is, it doesn't really matter where the range circle is in relationship to the line that you're cutting, but it does matter how smooth your input is. If you're sort of moving around too quickly, that may translate into the wood. It may leave kind of a little bit of a ripple in the surface of your cut. But if you're really smooth and consistent about your input, you're going to get a really, really awesome cut quality. Just like any other machine tool in the shop, trying to give a really consistent, smooth feed rate is the goal. Just like with the table saw, the router table, the more consistent you can be with the feed rate, the better the outcome is going to be. And Origin's really no different, because the cutting physics are more or less the same there, aside from the extra correction stuff, which sort of behaves in a very similar way. Let's see, Jake.
First side done. Get out of here. Bring that up front. Matching sides.
Ooh. I like the big box joints on this.
I'm digging it. It's working for me. So we just cut, what was that, part B. Now we're going to switch it to part A. Cut its matching part. Again, reference face. Have my little X drawn. Very important.
That's Jake's favorite topic. He loves talking about reference faces.
Reference faces. Pressing up.
Was that beaten into you at school, Jake?
No, it's been beaten into me here. I beat it into myself.
Oh, it was all me? So honored.
All right.
So, Jake's doing all this on Tool, and that's pretty awesome. But it can be a little tricky to figure this out. Jake, do you want to show? Maybe you already clamped that in there, but you showed me a spot where you made a boo boo. Yeah.
Yes. All right.
Let's celebrate that. Let's see it.
I got lost in the heat of the moment when I was cutting the mortises. Again, all the mortises were done on Tool 2, just using grids and the rectangle tool. I had a little jig set up, and I was using quick clamps, and I somehow flipped it the wrong way. And if you can spot it,
so you might have a hard time spotting it. Yeah, maybe you can show on the benchtop camera. I actually really wanted to show this because I think it's awesome to show. One, we're not human over here either. But two, or we are human rather. We're not human. The two that with Origin, it's actually really simple to kind of fix the boo-boos that you make. You can even make a celebration out of it and pop in something bright to kind of show that little mistake, celebrate that mistake. But
yeah.
It's really easy to. It's almost like you can treat Origin and making a Dutchman patch kind of like an undo for woodworking, right? Where you cut wood away that you didn't mean to. It's actually pretty straightforward, so long as you don't remove the tape or kind of pull the reference away. It's really easy to keep working on that. Change the size of the cut that you made. Grow something if you slipped and made a mistake. It's really simple to fix that stuff. The other fun thing to talk about, though, is if you need help getting your work digitized into files so that you're kind of not doing the on-tool creation side of things. If that's not your bag, that's okay. Remember that with Origin, we want to make any way you want to create easy. So if you like the on-tool creation stuff that we've put in there, awesome, use it. That's why we're talking about it today. If you know CAD, cool. You can get files out of Fusion 360, SketchUp, all those things, Illustrator, Inkscape. And if you don't know those, but you kind of like the idea of having, kind of a cut file done, if you want to do something more custom, or you're just kind of having a little bit of trouble thinking through a design, we have a service called Assist. And you can actually just go to assist.shapertools.com and submit a request with just a little description, maybe a drawing, a photograph of what you're looking for, and Eric will get in touch with you and set you up a quote. And if you're into it, he'll make it for you and send it straight onto your tool. And so that's actually one of the I think one of the coolest offerings that we have here at Shaper, because it just sort of opens up your time to do other things. You can just sort of send in a drawing, and the other cool thing is Eric is also an expert fabricator, and he'll be able to help you think through the best way to do something, materials, what cutters to use. It's not just a sort of he throws the design your way and says good luck. There's definitely a good relationship there. So give it a try if you haven't tried Assist, and let us know what you think.
Cool. All right, one more time. I just want to show the ease of swapping. We already cut our A part, or rather we cut our B part, and boom, just like that, we're ready to cut A. Same dealio, pocket first, inside cut next, work to your final offset, which is 0 in this case, And I'm going to do a test fit, even though this is what I've cut all of my box joints to, so I know it's going to fit nicely. But just to reinforce the idea, always test fit before you take it out of the workstation. All right.
So just as before, Jake's going to pocket first to clear out the center areas, and then he's going to set up his inside cuts and do a couple of finish passes. And like he said, now that he's cut one side to 0, he'll be able to use that side to test the side that's still clamped up into workstation while it's still clamped up. Or, really, even if you take it out, workstation's reference surfaces are reliable enough that you can stick it back in if things aren't fitting, and you're likely to be able to do a pretty good job there of getting things to line back up again. But if you leave it in there, your chances are more or less 100% that you're going to be able to make that adjustment, and that's always good. So always leave things clamped up if you can, or leave shaper tape on your projects for as long as you can, because it sort of allows you the freedom and insurance policy to go back and make adjustments if you need to. It's pretty cool. And even if you leave the tape on there for weeks and go on vacation, come back, you should still be able to get that workspace opened up and still see the history of that workspace and all the files that were placed on it, and be able to make adjustments and cut things differently if you need to. And that's really quite a powerful thing. Especially on the the leaving shaper tape on side, right? You as long as it removes that workspace, you're good, which is a pretty unique thing. So let's see here. What else can we talk about? The workstation has some pretty cool features, and you can see Jake's sort of cutting into a piece of MDF behind the piece of cherry that he's working on, and that's a spoil board that we put there so that you can cut into it. And like Jake said, you can adjust the clamping face up and down, and there's a couple different sizes. So you can use either 25 millimeter spoil board or 50 millimeter spoil board, depending on how deep you're going to be cutting. So, but what's great about that is actually there are these what we call tensioning cams that are behind the spoil board, and you can actually use those to apply a little bit of force against the back of your material, and that's really just to help with tear out. Especially when you're able to do these as a pocket first, you can control if you're plunging in to the front of your material, and then going front to back on your cut. Then all of the force is kind of going out to the back side when you're leaving, when your bit is leaving the piece of material that you're cutting. And so that spoil board behind really helps keep the tear out to a minimum on the back side. And then, you will be, there's a tiny potential for tear out when you're following the inside cut path like Jake is doing, but it's really minimal if you're not taking massive cuts at any kind of large amount of material at a time. You're going to sort of maximize your chances of tear out not happening if you take kind of little, very gradual passes. And the other thing that you can do as an insurance policy is just put a little bit of painter's tape on the front edge and really give that a good press down with the palm of your hand. And that'll act, the adhesive on that will act as almost like a little spoil board clamp on the front. And it will help keep kind of the minor tear out from happening. It will keep the wood fibers together a little better on the right-hand side of all of those pins where you're more likely to see tear out happen. That said, if you keep your cutters clean, and you're paying attention to your feeds and speeds and sort of how much you're taking off at a time, and by feeds and speeds I mean sort of the setting on your router, the speed setting there, and the feed is just how quickly you're moving the cutter along the toolpath. And one thing that we can take a look at is auto mode. You can actually control that. So if you're having trouble, you can sort of slow the speed way down and use auto mode. You always want to remember that you're trying to sort of match your cutter speed to your feed speed so that they're kind of symbiotic. You're not burning your material by having the cutter running too quickly, and you're not tearing out by having the cutter or leaving a scrappy surface by having the cutter run too slow. You're trying to find kind of the just right Goldilocks in between of those. And I encourage everyone to start slow, because you're more likely to see if that's problematic on the slow side. You can hear it, you can feel it, test it out. But if you start too fast, more likely than not, you're going to burn your material and cook your bit. It's just it's gonna destroy the nice sharp edge on your bit if you run your router too quickly.
All right, I'm very happy with that fit. A couple of taps with a mallet, and it'll come together beautifully. Just nice and squeaky.
Yeah, sounds nice.
I'll pull this out of my workstation.
So what's next, Jake?
So, next, you're probably wondering, I've already cut my slot for the back of my cabinet, but it's blind. Normally you do this on a table saw or something, and you have to cut all the way through. I'm going to show you how to do blind dados for your drawer bottoms or your cabinet backs with Origin on Workstation. First things first, move this to the side and bring my drawer over. I've already cut the box joints on my drawer. It's ready to go. All but one drawer slot is done. So we're going to use shelf. We'll bring our clamping face up to the top level.
I always like this shot because the camera goes for a ride on the clamping face. It's my favorite one.
There we go. And get rid of these clamps. You're not going to need them for this. Bada bing, bada boom. Shelf. Up here. There we go. Slides directly down into the clamping face. Voila. I'm going to loosely tighten that so that I can apply a little bit of double-sided tape to the back of this. And I'm going to put my on-tool rectangle right here. So I'm going to use grid, but I'm going to grid behind the piece, and I'm going to show a little technique for that. First off, a little double-sided tape. Not doing a super aggressive cut, just a single line. Well, we're making a rectangle, but it turns out to be a single line because our drawer bottom is a piece of 1/4 inch. Most important.
So that double-sided tape there, Jake, that you're using, that looks mighty fine.
It is indeed. There's a reason we sell it on our store, and you too can have it. So
yeah, that's tape that we've been using in the Shaper Shop for years and years and years. It was originally designed for attaching attaching a new handle webbing or handle cork to golf clubs or something like that. But it really works. It's pressure sensitive. You push it down, and it's extremely strong in shear. So if you're pushing, to the left or the right or forward and backward on it, it's not moving around at all. But when it comes to kind of getting your cork back up again, you just slip a little spatula underneath it and you pop it right off. Pretty amazing stuff.
Okay, so double-sided tape onto the shelf. I used just the edge of my shelf as an alignment, and I also pressed my piece up against, you can give me that top camera, thank you. Pressed my material up against this edge and then aligned with this edge of the shelf. That way this process is totally repeatable. I'm going to grid off this side so that every time I put another piece up there, it's referencing that same edge. It's all about reference faces. There he goes.
Oh, right. It's always all about reference spaces, Jake.
And say,
hey, are you leaving the are you leaving the dado slots a little long? Is that why it's okay to kind of just eye the placement there rather than using
yes,
like a hard stop?
They are going a little long. I am leaving about 1/8 of an inch on the outside, so it's delicate, but I want enough room for my slide to go for my bottom to go a 1/4 inch into all sides of the box.
Makes sense. And it's kind of a win that you don't need to be too fussy about exact placement. It's like,
right.
Yeah, lines up, feels good. It's lined up to the edge.
And I only need to worry about it too on these long faces. They're the blind ones, but the shorter faces, as long as it's pressed up against that workstation edge, I'm cutting through both sides, and I don't need to worry about it.
Got it.
Okay. Gridding off of... Let me go ahead and readjust this camera. Should be able to. Without it getting in my way. New scan. As always. Want to see what we're working with. Moving origin smoothly. Side to side. And then just want to get a nice, good, clean image of that piece. I've gone ahead and marked too, just for my sanity's sake, where that groove is going to be. On which face, which face I want external. So I put a small pencil line right there, and that's the bottom of my drawer side. Create a grid. Now, I am plunging my probe directly into these channels. I know it might be difficult to see, but these channels that the clamps slide into, I'm going to plunge down into there and use the back side of the bit as my probe. Coming down.
So this is a really interesting one. You guys are going to want to keep an eye out on the setup and grid. So there's this little button down on the bottom there. Yeah, Jake. And you can swap where the reference edge is going to end up on your grid. And so, yeah, obviously Jake wants that bottom edge of his cutter. You can kind of see this top of the slot there on the screen. If you guys have a workstation at home, that's the slot that shelf sort of tracks into, or there's actually two sets of them, the vertical ones.
And then finally on the left side. Cool. Back into our create tab, just going to create a rectangle. Oops. My width is going to be 13 inches. My height, I'm going to do 0.26 just to make it slightly larger. I could make it 0.25, the exact size of my cutter, but I'm going to use an offset instead to do that. So if I need to make my dado slot slightly bigger, I can do that quickly and easily.
It's also sometimes if you create geometry that's the exact size of the cutter that you're trying to use, that can be problematic actually for anything, any kind of computer controlled cutting system. It's sort of an issue of trailing zeros and things I don't understand, but have been explained to me many times. But the long and short of it is, if you make it 0.26, or if you make it a little bigger than the bit diameter that Origin or any other machine is trying to squeeze into a space, then it's really easy for the machine to do that. Sometimes, if you make it the exact size of the bit, it has trouble making those calculations.
Yeah. So now that I got my shape built, I am grabbing it by the top middle. I know my material dimension is 14, or roughly 14. So I'm splitting that in half. 6.625 is going to land me right in the middle, and I'm stepping down a negative 0.25. So if I zoom in, you can see that's going to give me 1/4 inch from the bottom of my drawer, and I'm happy with that. Again, I've placed it. Now I can just come over here and double check. Yep, that looks good. And that looks good.
And it's important when you're doing on-tool design work that you kind of be cognizant of setting up the dimensions so that they're easily divisible by the value that you set up in your grid. So just thinking through kind of the dimensions of your project when you're designing it, you're planning to build it on tool of origin, just make sure that if you're trying to nail that slot in the middle of the last box joint, that the pin of the box joint, that the size of that pin is roughly divisible by the grid that you're planning on using to lay this all out with.
Yep. Okay, I'm going to do this in one shot. I'm going to test fit and see if I need to adjust anything.
So as you can see, as I was saying, that makes just a really skinny little line down the center. So essentially Jake's cutting a slot, but it's just slightly oversized. But yeah, if you just make it that slightly bigger, oops, Jake caught himself there. Always good to check and double check your cut depths. Sometimes that's a gotcha, where you're plunging deeper than you don't want to. But the other cool thing here is that in cutting slots for a dado, it's really easy to size for your panel, right? And it's not something that's so easy if you're using a dado stack. Obviously the blind aspect of these dados is also quite cool, but being able to easily adjust for all sorts of different material thicknesses that you're dealing with in different brands of plywood means you're not dealing with shims in a dado stack, which is always good because that's a pain. So Jake's just going to finish this line, try it out, and then he's just going to come across. I don't think you're going to go back around. He is going to go back around. So he's making that slot 2.26 inches. You could also just go across and not coming back around and test before you kind of do the opposite side, which would just leave you a 1/4 inch slot. Looks like we're there and ready to give that a test fit.
And that's perfect. I want it to be able to slide in, but still not wiggle. I'm very happy with that. Quick sand of that edge.
It's the ASMR section.
All right.
See, easy peasy with that double-sided tape, but it never moved.
It never moved. Sometimes I get it. If I over tape something, I'll have to wiggle a very thin, flexible scraper underneath it, kind of twist it. But I'd rather it be secure and not leave behind residue than.
Totally. Or you can play a game. You can see how little you can use to make it secure. It's a dangerous game.
It's a very dangerous game.
The game you play when you're getting down to the bottom of your roll.
Yeah. Okay. There we go. That's the final piece of my drawer set. I'm going to go ahead and pop that together. May require just a little negotiation with
We're
it
going to
now.
have to start selling that hammer, I think, Jake.
I love this hammer.
It's in every session.
Yeah.
Sweatbands and hammers. It's on the list.
It's what the people want
You
now.
heard it here first.
And finally, light taps.
Yeah. That looks just dandy.
It's so satisfying. It's like assembling a box joint and having it just beautiful. Having it just snap together. I said I'm really happy with that amount of resistance. I think that friction fit's going to be good. Plus glue, it's not going anywhere. All right, let's do the case. Same deal.
To see it all come together.
Yeah. I'm going to start with our bottom. I went ahead and marked my sides too. left and right, really just for grain orientation. This is the way I want it to come together. There's my L. Boom. I'm going to sneak in my back.
Where's the cherry plywood, dude?
Trust me. really wanted to make a thin sheet of cherry. I still might get creative with it. There's a couple other funky parts to this design that I'm happy about. I decided to use red MDF as a shelf, which I'll show in just a moment, and as a drawer front. So it's actually just right here. It's this beautiful dyed MDF. So it's red all the way through. It is beautiful, like once you get finish on it. So I know MDF, why would you use that? But once you throw a finish on this, I think the red pop of that plus the combination of the cherry.
If anyone's seen our friend over at Normal Design, Simon, who's been in quite a few of our videos, he uses that MDF quite often. I think one of the coffee tables that we have in one of our videos is made out of that same stuff. And yeah, it's just it's such a cool material.
It's beautiful. Yeah. He does like a gray, like a charcoal gray.
Yeah. Yeah.
And there we go. Top case ready for action. Now flip that over to expose the mortises. Now here is a tricky part. You may have noticed these little cuts. All done on tool. I just used the rectangle tool. But this is where my lower MDF shelf is going to fit into. And I'm not going to try to do it up here like this. I will move this out of the way.
I was going to say, after you showed the force with that stool that we did a couple of weeks ago, I think you can assemble anything on sessions. Take through like 7 extra arms.
Yeah. All right. So what I did, again, in the effort to keep this entirely on tool, I used an 1/8 inch roundover bit to round over the front and the top and bottom edges. That way, when I cut this rectangle, it leaves behind a radius corner, and with a 1/4 inch bit, that's going to leave me an 1/8 inch radius, and it's going to fit beautifully. Nice and squeaky. Okay.
Make sure Jake did his math right here.
Exactly. It's always fun to do these kinds of things live. There that is. Yeah.
And Jake, if you were doing this, for real, or rather doing it as a glue up so that you're not trying to grow extra sets of hands, what would be the kind of order of operations you'd take?
Well, I'd have all my cases glued up first. Make sure that they're band clamped, glued, square. That way when I come to this leg, I think I would do the leg section all entirely on its own, and then the mortises as well, into the mortises, mainly because all of these parts are playing a role for each other. The shelf is actually also going to bind things together quite a bit, and so it's not just these two. It is a rather slender cabinet, so it's not just, it's got a little extra support there.
Seems like it's holding itself together pretty well, though.
Yeah.
Impressed. Never doubted you, Jake.
Noah. All right. Let's flip this here. Doo-doo-doo. Voila.
This is going to be cool. I like this little table.
It's for a very small area that just needs something. It's like it's the reason it's so tall actually is for like everyday carry stuff. So it's a place to empty your pockets, put your phone, your wallet, keys, what have you. Beautiful. And a couple of tippy taps.
Oh, man, love watching those gaps disappear.
And there we have it. I think it might be too tall to actually show on camera, but is it? Not quite.
Yeah, no.
And so it's going to also have a red face with probably a that gold campaign pole, which I can show you actually right here. So it's a flush-mounted campaign pole that, if you've seen us at shows, we love this thing. It's a great demo. I just think it's also a beautiful pole.
Yeah, check it out on Shaper Hub. You can download the file for that. And I think there's a link in the Shaper Hub project for that little piece of hardware. It's an awesome little one.
That you can. So I'm going to do the drawer slides as well. I got a couple full extension drawer slides that I'm going to put in there. And that is my long, tall box joint cabinet.
That was awesome, man. Well done.
Thank you. Thank you, everyone, for joining us. Oh, I want this to.
I was gonna say, and we'll just leave Jake to it. He's gonna just keep tinkering.
Yep. Don't mind me. Thank you, everyone, very much for joining me and Noah on this journey of box joints and box joint applications.